Hello everyone, my presentation is titled From Tracking to Algebra for All, the Historical Development of Algebra 1 as the Gatekeeper of U.S. Secondary Mathematics Education. As I prepare to teach Algebra 1 this year, I wanted to understand why this course has become so important. Through my research, I discovered that Algebra 1 did not become the gatekeeper overnight. Instead, decades of educational reforms, tracking practices, and policy decisions transformed one mathematics course into the gateway to advanced mathematics, college readiness, and future career opportunities. When I chose this topic, I simply wanted to learn more about the history of the course I'll soon be teaching. As I read the research, however, I realized that Algebra 1 represents much more than a required math class. Today it serves as the prerequisite for geometry, algebra 2, higher math, many STEM fields, and often college admission. The history also reflects larger debates about the purpose of mathematics education. Ernest, in 2004, explains that mathematics education has always been shaped by competing beliefs about who mathematics is for and what its purpose should be. Some philosophies emphasized mathematics for a select group of students, while others argued that rigorous mathematics should be available to everyone. The history of Algebra 1 illustrates this shift. My goal today is to show how tracking, educational reform, and the Algebra for All movement transformed Algebra 1 into the gatekeeper of secondary mathematics education. To understand why Algebra 1 became the gatekeeper, we first have to understand tracking. For much of the 20th century, secondary schools placed students into different academic pathways. Some students entered college preparatory tracks, while others were placed into vocational or general education tracks. According to Gamoran and Mayer, these tracking decisions significantly influence students' educational opportunities because placement often determined which mathematics courses students could take later in high school. Students placed into lower tracks frequently had fewer opportunities to enroll in rigorous mathematics courses, reinforcing educational inequalities. Tracking wasn't just about organizing students, it shaped their future and academic opportunities. As high schools increasingly organized mathematics into a sequence of courses, algebra became the entry point for everything that followed. Students who successfully completed algebra could continue into geometry, algebra 2, pre-calc, and eventually calculus. Students who struggled or failed algebra often found those opportunities closed. At the same time, colleges began expecting students to complete more advanced mathematics before graduation. Because algebra became the prerequisite for nearly every higher level math course, it gradually evolved into the gateway for college readiness and many career pathways. Reck and Harrington describe algebra as the true gatekeeper because success in the course influences whether students can continue toward degrees in business, engineering, science, technology, and many other fields. They also note that this gatekeeper role has historically had a disproportionate impact on underrepresented students. This, I believe, is the major historical turning point in my project. Algebra was no longer just another mathematics course. It became the course that determined access to future academic opportunities. Once educators recognized the importance of algebra, many began asking an important question. If algebra opens so many doors, shouldn't more students have access to it? This question led to the Algebra for All movement during the 1990s and early 2000s. Rather than limiting algebra to students already identified as high achieving, reformers argued that more students should have the opportunity to enroll in rigorous mathematics courses. Gamoran and Hannigan found that students from a wide range of background benefited from taking algebra, particularly when schools provided appropriate instructional support. This reform also reflects what Ernest describes as changing philosophies as mathematics education, rather than viewing advanced math as an appropriate only for selected students. Educators increasingly argue that access to rigorous mathematics should be available to all learners. As Algebra for All gained support, many districts began offering algebra in 8th grade. Spielhagen's research found that students who completed algebra earlier remained in the mathematics pipeline longer and were more likely to continue into advanced mathematics courses and attend college. However, the study also emphasized that simply moving algebra to 8th grade was not enough. Students needed strong preparation in earlier grades and effective instruction once they reached algebra. This illustrates an important lesson. Expanding access works best when it's accompanied by meaningful support. Although Algebra for All increased access, implementation proved challenging. Nomi studied Chicago's Algebra for All policy and found that schools created more mixed ability classrooms after eliminating remedial mathematics courses. While access increased for many students, teachers faced the challenge of meeting a much wider range of learning needs within a single classroom. High-skill students also experienced low peer ability levels and in some cases lower test scores. The lesson isn't that Algebra for All was a mistake. Rather, it demonstrates that expanding access alone does not guarantee success. Instructional support and thoughtful implementation remain essential. The history continues to shape today's classrooms. Nearly every student now takes Algebra 1, but teachers continue to face many of the same questions educators debated decades ago. How do we maintain high expectations while supporting students with very different levels of preparation? Sculpsmore argues that mathematics education should promote social justice by creating meaningful opportunities for students to succeed, not simply by increasing access to rigorous coursework. In other words, enrolling students in algebra is only the first step. Schools must also provide the instruction and support necessary for students to learn successfully. As someone preparing to teach Algebra 1 this year, this research changed my perspective. My responsibility is not only to teach algebraic concepts, but also to help students successfully move through one of the most important gateways in their educational journey. The history of Algebra 1 demonstrates that educational reforms are rarely just about curriculum. They reflect changing beliefs about equity, opportunity, and what mathematics education should accomplish. Tracking restricts access. Algebra for All expanded opportunity. Today's challenge is making sure access is matched with meaningful preparation and high-quality instruction. My biggest takeaway is that Algebra 1 continues to be the gatekeeper, not because of the mathematics itself, but because everything that depends on the success in the course. I'd like to leave you with this question. If Algebra 1 continues to determine so many future opportunities, should our focus be on requiring every student to take algebra or on ensuring every student is truly prepared before they get there? These are the scholarly sources and course readings that informed my presentation. Thank you for your time.